So I'm really excited about this, and I'll stop sharing here, and we'll transition momentarily to our presenters, but they deserve an introduction. We're lucky enough to have three presenters today, and I think George is going to kick us off. So George is a professor and extension specialist at the Department of Agriculture and Resource Economics at the University of Arizona. And importantly, he's also a co-PI, co-principal investigator with CLIMAS, and that's the Climate Assessment for the Southwest or program at University of Arizona. And George can tell us the CLIMAS acronym because I'll get it wrong. Um, uh, and then we have Dan, who's also an associate professor of environmental science and director of the Climate Assessment for the Southwest, the CLIMAS project at University of Arizona. Dan is a qualitative social scientist who contributes to and leads interdisciplinary teams that conduct place-based and problem-oriented environmental research, like what we're talking about today. Perfect example. And finally, we're also lucky enough to have Mike on the line. And Mike is faculty of the Department of Environmental Science at University of Arizona as well, and has another hat he wears as an extension specialist in the climate science for Arizona Cooperative Extension. Mike's been there for 20 years, working with ranchers and farmers, natural resource managers across Arizona to integrate climate information in their planning and decision making and assist in developing strategies to adapting to this warming, drying climate. So really pleased to have all of you on. I will be monitoring the chat. So if you have questions while they're talking, just go ahead and put it in the chat. We'll answer it in the Q&A towards the end. And I think with that, we can let you take it away, George. So thank you so much.
Well, thank you. Let me see if sharing works. Is that working?
Yes, we're seeing yes, there we go. Perfect.
Okay, so this study really was a case of, I'm sure a lot of you are familiar with that meme where it has a part where it says, how it something like how it started or how it began and where it's going. Because where this project went really is very different from how it began. And how it began was, I'm an economist by training, looking at the value of information. And there's a whole host of different kinds of value of information studies that have been done. And the basic premise is there's a benefit if you make a decision with information. And if you didn't have that information, you get some kind of payoff or benefit from doing that. And so the net benefit of the information is how much better your decisions and outcome are once you have the information, and there's a deduction for the cost of actually acquiring and using the information. And this has been used a lot like in agricultural contexts, and there's been a lot of work like looking at the value of ENSO forecasts or freeze forecasts for ag production. That's one example. In theory, this could be done for improved fire management decisions. And when we were starting this grant, I had looked at some really interesting things that economists at the Forest Service were doing for forests in the eastern half of the US, looking at how you could use improved drought information to have better forecasting and make better decisions about, for example, hiring crews for the upcoming fire year. And so I thought, oh, this is a great study. We could do this for the Southwest because no one had ever done something like this before. So we had proposed to do this. And then I had contacted the folks at the Forest Service about, well, how are people using, this new kind of data and forecasting source and product that you develop, how's that working? And they said, well, no one's really using it. And I thought, oh, well, that's interesting because they had kind of demonstrated there was this high potential value to using it. And I was talking with them and I said, well, we got to this question. It's like, well, why aren't people using the information? What information are people actually using? And their response to me was, boy, if you find out, could you let us know? So exploring this a little bit more, we realized the linkages between information use and better decisions and better outcomes was more tenuous than we thought, or certainly more than I thought going into it. And so we took a step back to say, well, what information sources do fire managers actually use, and how do they use them? What do they use them for? And a thing that struck me, again, being an economist, is this notion of supply and demand. And a lot of policy discussions and academic literature really focused on the supply of new products. Like, here is a new tool, here is a new information source, here is a new platform that is promoted as improving fire management decisions. But there's a lot less attention paid to the demand side of the equation. So what sources were fire managers actually using? And then are specific information sources actually used by people to make decisions? And what I'm going to talk about is a paper was out this last year in Atmosphere with Mike and Dan, but also my grad student Ning Zhang and Chuck Maxwell, formerly of Fish and Wildlife Service. And so we approached this, and Dan will talk about this qualitative analysis next. We did focus groups, we did interviews of fire managers, but then we took the names from the Southwest Area Interagency Fire Aviation and Dispatch Directory. So this is kind of the universe of Southwest fire management decision makers. And we developed a Qualtrics internet survey of these folks in the directory. And initially we took out people who were like budget folks or clerical people who are obviously not in our study population, but then we had a screening question about whether people used weather and climate data and information to either make decisions or to inform decisions. And so when people responded back positively, some people responded back that they were no longer in that position, or they didn't use data for that purpose, and so that those people really weren't our population. But of folks who actually were using data for fire management, our sample of respondents was actually, I was very pleasantly surprised about how representative it was. And you can see, we know the agencies folks worked for from the directory. So we have a kind of the universe of possible respondents, and you can see that our sample population, the proportions, at least by agencies, is really representative of the population we were trying to target. And our response rate was a fair bit higher than other published studies trying to get fire managers to actually respond. So one of the things we were looking at was, what's the total number of information sources fire managers used to make decisions? And the response was broken down by before fire season and during fire season. And two things you can notice here is that there's a lot of variation in how much information different folks use. So kind of both before and during fire season, kind of the mode response was between 13 and 15. But you have everything from people using 3 or less sources, or at the high end 31 to 33. So there's a lot of variation. So why are some people using a lot more information sources than others? So we developed a kind of simple economic model based on kind of earlier economic models of demand for information. And so very simply, we assume managers are going to use they're going to use an information source if the expected benefit exceeds the cost, subject to some kind of overall time constraint. And the cost to people using the source. Could be their time cost. It isn't necessarily monetary cost. And people are facing a time constraint. So the idea is that, right, if fire managers are going to use an information source if they think they're going to benefit from it, and they don't use the information source if they don't think they're going to benefit from it. And so we use this kind of simple demand for information model that's been applied in a lot of context to fire management. And we used it to generate some hypotheses about what's driving that variation in the total number of sources used. And so our little economic model spits out various kinds of hypotheses. The first one is that managers who make more decisions are going to access more information. So basically, the more decisions you have to make, the more chance that better information will make each one of those individual decisions better. So the more decisions, the more information people will seek out. In terms of fire season, I think things could go either way. During fire season, you have resources that are at immediate risk, which you would think would increase the demand for information sources. But during fire season, things are literally on fire. So you don't have a lot of time to be seeking information. And so you're going to have two effects. One is the higher potential damages during fire season, which you think would increase demand for sources, but then there's time constraints, which may limit it. And so the net effect is going to depend on which of those things are stronger. We also hypothesize that managers who are operating at a regional scale are going to access more information than those at a local scale. So the idea would be the folks at like the Southwest Coordinating Center would seek out more information because a given amount of information could be applied to a wider area. So with a lot of these information sources, you're asking questions about things over a broader area. So if you're managing a broader area, you might be expected to use more sources. We also hypothesize, again, this is from other literature, that if you have formal education, that's going to encourage information use because you have more technical capacity, you're better able to process and utilize information more effectively. Age and experience can have countervailing effects. Managers can have on-the-job knowledge via experience, and some past literature has shown that fire managers with more experience often use less information because they don't have to consult as much independent sources. They kind of think they know, or they do know, what they need to know, and they're not spending a lot of time searching. Conversely, younger and less experienced managers, they may be more comfortable with a lot of these newer, web-based platforms, more technically challenging things. So that could be a benefit. And so age and experience could signal more on-the-job knowledge, but you could be younger and less experienced. So you might just have more facility with more current information technologies. Again, previous literature on information use suggests that decision makers, their occupation or role within a system is going to affect their demand for information. In this case, their system is a fire management system. And also, the agency where people work is going to have an effect. The dispatch center where people work is going to have an effect because this is going to affect the overall environment where they're operating. So we tested these hypotheses with a regression model, and the way hypotheses or tests are done is you have a null hypothesis, which is basically the null hypothesis is like nothing is going on, and the alternative is no, there's an effect going on. And so couches the null hypothesis. It's like information use is independent of the number of decisions made, and we rejected that. We found that yes, the more decisions people made, the more information they used. Information use does not increase during fire season. That was the null. That was rejected. We found that people used more information during fire season. And then there are joint hypotheses. We have like hosts of dummy variables for which dispatch center someone is, their level of education, their age, experience, their jobs, their agency. And in most cases, the null is that these effects don't matter, and really except for age effects, we fail to reject that, so that there's something going on where all these effects are statistically significant. In terms of job description effects, the main thing was that administrators tended to use fewer information sources. In terms of age effects, it was a really strong positive effect of being 30 or under. Those folks tended to use a lot more information sources. So that was kind of the good news, was that we developed this little economic model to explain how much information fire managers use, and we had these hypotheses about what factors we thought would matter. And by and large, the results can confirm the hypotheses that come out of this simple economic model. That's the good news, but there's a lot of challenges. There's a lot of questions that remain. So the model R squared had values between 0.28 and 0.3. So that means that we're not explaining about 2/3 of the variation in fire manager information use. Our model is explaining about 1/3, but there's another 2/3 out there that we're not explaining. The other thing that I found interesting was again, economists focus on private decision making by individuals a lot, and it often focuses on individuals' personal characteristics. And when the R square was 0.28 from a stripped down model, because we had people not responding with data for their personal characteristics. We had another larger model where it had their personal characteristics. The model fit really didn't improve all that much when you included the personal characteristics. So what was really driving things were the context of their work, not their personal attributes. And so we found that there were strong dispatch center effects. So which dispatch center you were at had a strong influence on how many information sources we use. Well, in the framework we use, we find that dispatch center matters, but we don't know why dispatch center matters. We also found that there were strong agency effects that were highly statistically significant. But again, we don't know what about the agencies affect their use of different information sources. So we're finding that the context of their job matters a lot more than their personal characteristics, which calls for future research and looking at, well, what is the nature of the job environment? What's the nature of their decision-making process on the job in different agencies at different centers? And what are the group dynamics going on there that are affecting information use? Well, thank you. There's my contact information. And then Dan next is going to go into a lot more detail about specifics of what we found managers doing and not doing. Let me get out. And
Thanks, George.
I'm trying to, there.
Can all see that okay?
Yes.
All right. Thanks for having us today. I'm going to dig in, like George said, on essentially the same data set. This is from a second paper in the series here. So first, before I do that, I want to just acknowledge the funder for this, which is the Climate Assessment for the Southwest program. And this program is focused on doing kind of exactly what this project is, which is science to support decision-making. We're focused in the Southwest. Many of you are probably familiar with our program. This is funded by NOAA. Crimmins has been in this region for 28 years. So we're a long-term program. Of course, right now, like a lot of climate funding, we're threatened, but for now we're here. But our goal is to do, Mike, George, and I are all part of this program. Our goal is to do science that sort of, it makes knowledge that's useful for people. So that's what all three of these talks are focused on. So this is from a second paper, which is in Weather, Climate, and Society. And this is based on the same data set that George has talked about from the survey, but it also incorporates qualitative data that we collected. So this paper, this analysis focused on two questions, very closely related. One is how is weather climate information used in wildfire management decision-making, as George has just described. And a second question is about basically the same question, except focused on decision support tools for Southwest fire management. Just quickly, a little more detail about what George just talked about, the survey population. So this, as you mentioned, came from the phone book, basically, for all Southwest fire professionals. So we had access to essentially the entire population. We had about 477 people who were relevant, as George described. We weeded out people who wouldn't use this stuff. With 206 respondents, which is a 43% response rate, which if you have ever done a survey, that's pretty darn high. Here's the breakdown of that population. I'm not going to bore you with the details, but the important thing is the region, obviously it's the Southwest, it's defined interagency fire. It's Arizona, New Mexico primarily. So that's where most of our respondents came from. And as George noted, the population, I actually didn't note this part, the population skewed a little old, which I think does represent the fire management community. So the age, 40 to 59 was the largest population that responded. And then similarly, people with a lot of experience, greater than 15 years. And most of the population had greater than 20 years of experience as a Southwest fire manager. So we have a very experienced population, and we got a pretty good response rate. So I feel okay about this data, I got to say, survey data. So what do we ask about? So we, as I mentioned, Crimmins is a climate research program, so we're focused on these questions about weather and climate. So we put together a whole giant list of weather and climate sources that are available to fire managers. So we binned them a little bit on the survey, so it was a little less unwieldy. So the first category was general websites and data portals. There's 10 of those. Forecasts and outlooks, there was 9 of those. And then what we wound up calling situation reports and information products, and there's 9 of those. Those are more digested, sort of synthetic products, primarily aimed directly at fire management. General websites and data portals are not necessarily aimed at fire management. These are kind of general public access data sources. So sorry for the unwieldy figure, I'll explain it. So this is all of those sources, and I'll explain what we're looking at in a second. Based on, this is the analysis of our that survey data. So the red text is highlighting the stuff that's actually made for the fire community. So you'll see a lot of those in the top part here. This is sorted by how many people use it. The black line indicates basically the 50% cutoff. So below the black line, less than 50% of the people said they used it. Above it, greater than 50% said they used the stuff. So if you just kind of start looking at it, you'll note a couple things. The first is it just the weather service, basically forecast, local forecasts are everybody uses before the season, during the season. As George mentioned, we asked before how information is used prior to and during the season. I'm not going to talk much about that, but because it's not a huge difference for this analysis. But you'll see that the weather service is, everybody uses it pretty much all the time. Another interesting thing is that, as you would expect, and this is obviously good news, a lot of the stuff that's made for the fire management community is in that sort of top 10 and is used all the time. Of course, there's good reasons for this. It's distributed by the fire community to the fire community. It's made with input and so forth. So this is a good sign. So one take-home message from this, so I'm going to go back though a second. So the thing that's kind of interesting, if you really start looking at this data, is there's a lot of stuff below that black line. So there's basically a lot of stuff that the science community is producing that is not used as intended. And if you're down less than 50%, it's not that many people who work in this business. And so you have to sort of think about what you're making. So one of the take-home messages is that relatively few of these sources are actually consulted, but those that are consulted, a lot of people use them. right? So that's good news if you're on our side of the equation. George talked about supply and demand. He's an economist, I'm not. Uh, we're on the kind of supply side, right? And so we're thinking of this as how do we make stuff that's useful? So you can see there's a lot of stuff that is useful, but there's a lot more stuff that's not useful. So if you can nail the sweet spot and get something that actually people understand and want to use, it will get worked into decision processes, we believe. So we also asked about a set of decisions, like what's this stuff used for? So this is a breakdown of that. So on the right side, you see the decisions, and we have a set of 6 kind of categories of decisions. And then on the left side, you have the sources of information. Again, kind of following the theme here, 13 of the 32 sources that we asked about. In this case, this included all of the climate and data sources, weather and climate sources, as well as the decision support tools. I'll talk about that in a second. So only 40% were reported to be consulted by greater than 25% of respondents. So in other words, most of these tools are not sources for informing decisions by most of the people that we surveyed. So that's not great. So here's that data in a nutshell. I want to highlight here that WFDSS was the only decision support tool of the 4 that we asked about that actually kind of made the cut line at 25%, which means that most of those decision support tools, right? That's what they're called, decision support tools, were not used to inform these specific sets of decisions, but they weren't used for that. I'll note that WFDSS, as most of you probably know, is actually required to be used by policy. And so the fact that WFDSS is in here is sort of obvious. It should be in here, but the numbers are actually pretty low on how much the folks use them. So if you look in the middle of the plot or the table here, there's 2 types of decisions that people use information to inform the most: asking for resources and prescribe fire, basically. So obviously these are high stakes decisions. Obviously this makes the most sense. This is very obvious data. Like if you're going to plan for prescribed fire, you're going to look at all sources available to you. And of course, WFDSS being used there, it's required. So again, a take-home message from this, very similar to just the bigger climate and weather information. The stuff isn't actually used by that many people to inform decisions. It's kind of the take-home message here. So WFDSS specifically, we asked a set of questions about WFDSS, again, because it's the most commonly used, because it's required to be used, but it's also kind of a central tool for wildfire management, not just in the Southwest, but in the United States. So how is WFDSS actually used? So we asked a set of questions about how people use WFDSS. So the first question here, I rely on WFDSS extensively to inform my fire management decisions before I make them. So do I use WFDSS decision support system, right? WFDSS, wildland fire decision support system. You would think that meant you use it to make decisions. So it's about a third in each bin here. So essentially this suggests that a third of the people are saying, yeah, they use it before I make a decision. A third are saying, no, I don't use it before a decision. And a third are punting on the question. So the second question is about digging in on that point. And again, a lot of this is already in the literature, so we were informed by that literature. So these questions were designed to sort of probe at things that other people have found. I use WFDSS primarily to document decisions that have already been made rather than informing decisions. And so you get a majority there. 54% agree or strongly agree with that. So this suggests that WFDSS is used to document decisions. Again, this is what it's made to do. But you would think it would also be informing decisions. So this is the sort of final question about WFDSS. WFDSS decisions are completed and entered into the system after the fact. So yeah, everybody does that. I mean, in some ways you could interpret this question as you have to. WFDSS you're required to record a decision in WFDSS. But we're reading this again from the literature that exists, from all of our data. It suggests that WFDSS is basically used to document decisions rather than inform them. Again, not a novel insight. You know, many other scholars have looked into this and have found a similar pattern with this particular tool. So the question is why? And, you know, George is an economist. I'm a qualitative social scientist. We have different ways of thinking about this stuff, which is part of the strength of this team. So these questions came directly from the literature. Other people had found from qualitative studies that maybe WFDSS is used this way for various reasons. So one idea is that, you know, weather and fire behavior changes rapidly. It's a complicated work environment. And so that's why WFDSS is used that way. And it seems like that's true. Like basically the environment that you're working in is much quicker than the way that you could use WFDSS to support you. Similar question, operational tempo of fire is often faster than the capacity to manage to produce a WFDSS decision. Again, a majority of people agree with this. So what's this all add up to? I mean, essentially, we, the science community who either operational researchers who are providing stuff directly to wildfire management, or in our case, academic researchers who are throwing stuff into this information ecosystem, there's a lot of stuff out there. Like there's a lot of stuff out there. Our list of 32, we could have had it probably doubled it. And we would have seen, probably a similar pattern, maybe a few things popped up. A lot of it's actually not deemed to be useful, at least by the population we talk to. The stuff that is useful is clear, and it's not that big of a set. People do use the stuff, and the stuff they use, they really do use. But it's not a big percentage of what's available to them. And this is an important thing if you're thinking about, cutting edge science getting into fire management, which is obviously very high stakes business. You want best available knowledge and so forth. It's a tough nut to crack. You have to figure out how you're gonna, get this stuff into a complicated, high stakes work environment. So that's what we do, or that's what we've been doing for the last few years, and that's what we're continuing to do. Is, in our case now, we're sticking ourselves in the middle of understanding how fire community makes decisions, the decisions they make. How could we make stuff that matches that environment rather than just throwing another thing out into the ecosystem? So that is all I've got. So thank you for your attention. Mike's going to talk about a specific thing that this group designed called Burn Period Tracker. And it came out of this set of interactions that we had with, I didn't mention at the outset, but George did. Chuck Maxwell, who is a longtime fire meteorologist in the Southwest, is part of our team. In fact, he's kind of the key part of our team. Chuck pointed us toward a lot of interesting insights about the data that we had, and he also helped kind of point Mike toward making this thing.
Thanks, Dan. And thanks for that segue. That's exactly what I was going to say, is that Chuck Maxwell was really our spirit guide on this whole project. And having Chuck be an actual operational meteorologist, trying to do his job and hang out with us academics for week after week after week for a couple of years, I think we learned more than we probably brought. And so this is a hope to try to turn this information back out to the community. So burn period came out of this whole project. So we're studying information use, and what we're finding in these conversations, and especially working with Chuck, are some gaps and some opportunities for the science community to try to integrate and jump into this whole discussion. So that's what we're going to talk about today. This is actually the third paper of the whole project that we had published just this past year. Okay, so why track burn period? Burn period wasn't a term I'm familiar with. I'm a meteorologist, climatologist, been working here in the Southwest for 20 years. We've kind of gone one way in the way we analyze data, the types of data that we analyze, and especially in fire climate science, using a lot of gridded data, a lot of data that is actually based on interpolated maximum or minimum values from different weather station networks. And so in the fire community, we're learning is that the reliance on RAWs, the remote automated weather stations, is very critical, and that's hourly data. And so kind of coming out of George and Dan's papers, recognizing that fire managers are juggling all of these different indices and can have this information overload, recognizing and learning from Chuck that they're already using some heuristics and some indices on their own and have been doing for a long time. And so one of them that Chuck knew about, being both a weather service incident meteorologist and then working at the Geographic Area Coordination Center for the Southwest, was that they're using a simple heuristic of just counting the number of hours per day, using those hourly observations from the RAWs of when the humidity is below 20%. And we recognize this is probably a pretty Southwest focused thing, but that heuristic has worked for a long time. And it was really being calculated by hand. It was actually going into the Excel spreadsheet and then looking at those metrics. And so we saw this as an opportunity to use some scripting, some open source coding, and some new application programming interfaces that had come online to be able to grab that data and actually produce this tool in real time, and also do a little bit of science and try to understand how this metric relates to some existing climate indices, fire climate indices that we've been pushing from the academic climate science realm. So burn period is very simple. It's just simply the local count of hours each day with relative humidity less than 20%. We can do that programmatically really quickly, and it really serves as a proxy for critically dry 1 hour fuel moisture and gives us a sense for potential for fire spread. This 20% threshold is kind of in some of the literature, not really literature, but in the training literature. The National Wildfire Coordinating Group training manuals have this 2020 rule that they'll use for firefighters and fire behavior analysts. And we found in the literature some indication that 20% threshold is probably pretty reasonable for aligning with moisture of extinction values for fine fuels, especially down here. And we did some analysis in this study to try to see what the difference between a 10, a 30, and some gradations, and this 20% was kind of a sweet spot, and clearly was already working in the community. And so we just tried to help bolster that with a little bit of research. So the tool, which is available here, and I think Sandra will throw it in the chat if you want to check it out. And we had a bug in some of the code because some of the database had changed on the fire environment management system, which has just gone live this week. I had a couple of analysts text me today and say that it was down, so I fixed it and we're back up today. And it provides the real time from the calendar year start to date, uses the forecast from the Weather Service up to 7 days. And then what we add is some climatology analysis using the historical record for each RAWS station. We're pulling this for all 124 remote automated weather stations that are in the Southwest here, within the Geographic Area Coordination Center of the Southwest here. And that now standard period of record is 2005 to present, which we're calculating the climatology on it. And so these charts have the smooth 10-day average, have the forecast on there, and the plot is, there's a static element, and then there's an interactive plot if you want to dig into the data. Static element is so you can grab it, throw it in a briefing report, which we've seen. And then we also have produced some regional maps and some recent observations, 7-day forecast. And this was an iterative process with the managers of like, what would you like to see? Where are you going to use it? How are you going to use it? And so that's still an ongoing project. It's really evaluating the impact and the utility of this project going forward. We also, in this study, dove in, and I'm a climatologist, so I wanted to really understand this metric a little bit more and help to provide a little bit of context. So we did this climatology here. So this is January through December, and the dot is where those raws are, and the size of the circle is the amount of variability you see historically at those stations, and then the color is the median number of burn hours that you see per month. And so you'd see the natural progression of the climatology here. January, low variability, low number of burn hours for the most part because it's cool and quite dry. As you move through the spring, you can see as we get into May and June, the whole map lights up and we start to see that variability across the region. Lots of variability from day to day and long burn hours. And that's really kind of an interesting characteristic of the burn period, is that it goes up and down every day. And you can have short-term pushes where that burn period is long and then it can retreat. And then as you get into the monsoon, you can see from July into August, it collapses back down. Variability is very low, burn hours are very low, and that's related to that incursion of monsoon moisture. And when we went back in and I wanted to understand a little bit more on the attribution of the temperature versus dew point signal in every day. So that dew point is going to be a measure of atmospheric moisture. Temperature is just going to be the temperature of the day. And if you look here at the coefficients, did a bunch of linear regressions, all days in each month for all stations from 2005 to 2022. And you can see here that the variability that we see in each month is predominantly governed by daily variability in dew point, not temperature. And as you get into the monsoon, temperatures are actually quite high, but the dew point variability is quite high. And so actually tracking dew point variability from day to day becomes the biggest determinant of whether burn periods are going to be long or short. That was kind of an interesting finding, pretty unique to the Southwest. So operational uses, what we've heard is that it's useful for quickly gauging daily window of active burn period. So we can think about this as a different metric than, say, vapor pressure deficit or some of the other national fire danger rating systems, because we're utilizing the hourly counts within a day. So it has that sub-daily. So you're not necessarily looking at maximum fire, but you can look at duration now, which can be helpful for staffing. I think it's useful for public messaging. And then our study is tracking those interseasonal trends and then relaying them and plotting them on the climatological plots that we have here. And then having those percentiles, which we hope gives you a sense of the anomalous context of any particular values you're seeing. So the operational tool is running on a script every night that provides those updated maps to the Southwest region. I went ahead and developed a nice little, I think, pretty cool little shiny app here, which now pulls all the FEMS data across the country. So you can actually go in there and calculate burn period for any station in the US and also change the threshold. So we see this as kind of a research tool. If you're interested in thinking about burn period in your region, maybe 20% isn't the right threshold. So you can adjust that and actually see how burn period varies. So we see this as a possible tool to be able to expand what we're doing in the Southwest to other regions, but this is an initial step to do a little bit of background research. So the key takeaways here, the burn period tracker distills a complex weather data into intuitive, actionable metric, which we're trying to listen to what we've learned in those first two studies and do this engaged process and come up with these simple to use and actionable metrics. And we think it's a powerful complement. It's not a replacement for the traditional fire weather indices, but I think it fits in the toolbox and already was being used. And we're just trying to facilitate the easier use of it and utilization of it, and try to understand a little bit of the science behind it as well. So how it would relate to other things that are changing in the background, like temperature and moisture. So the tool is there. That particular link will take you to the Southwest one if you want to check it out. And then the paper that is detailed in this particular study here is open source. And if you click on that link, that'll get you there as well. So thanks so much. I think that's the full show, and then we're available for questions.
Great, thank you. It's a really cool to see how you all put these pieces together to connect data needs and then the data itself. Awesome work. Looking at our participants, please go ahead if you want to unmute. I believe you should be able to unmute yourselves if you just prefer to ask a question out loud. Otherwise, you can put it in the chat window. And maybe while we're waiting for that, for folks to get their thoughts together, get it in the chat, I'd be curious, where are you all headed next? This is obviously a ton of work. You're probably still trying to celebrate getting some of this stuff done, but I'm also guessing that you have some ideas for where you want to go next.
Mike, I'll start, and then you can. We have several threads. Andrew, thanks for asking the question. Thanks for the softball. Well, there's a couple things. We have just hired a postdoc, Tristan O'Mara, who I think is actually on this call. She just graduated from NAU with her PhD. So we're going to work with Tristan on one side of the kind of project team, which now includes, so it's Mike, George, me, now Tristan, Chuck Maxwell, who we mentioned, and also Cheryl Bright, who's a fire analyst, as part of this team. We're going to dig in, part of us are going to dig in on the understanding decision space, information use environment, like how does this stuff actually get used or not used, and why is it not being used? So we're going to go pretty hard on that set of questions. It's very much designed, obviously we can produce academic papers about that, but our goal is to inform then kind of tool development and better science. Because of course, we're all stakeholders in the West in having fire managers have the best available information. I live in an environment that burns, and so it's good we can improve that. So Mike, do you want to, so we're doing the sort of social science part of it. And then Mike's working on a whole other suite of things.
Yeah, I think probably to tag on to that too, Dan, is that the burn period tracker, what we're trying to practice what we preach too. So that is an evolving experimental product, and our broader team, especially having the social science expertise, is we want to continue to evaluate, like, is this right? is this what the way you think it's working? And continue to listen on that part of it. And the really fun part is that, well, unfortunately, Chuck retired from his position, and that's a huge loss, I think, for the Southwest. But we picked him up as a designated campus colleague, and he's working with us just for free. And so we have this pretty interesting Teams channel with Chuck and Cheryl. And Cheryl's still working as a fire behavior analyst up in the Midwest. So we're learning a lot. So we're trading a lot of ideas, and so we've got several research projects to try to identify how the RAWS network works across the Southwest and across the upper Midwest and the Northeast in relation to different fire metrics, trying to think about some innovations around the National Fire Danger Rating System, trying to evaluate how the new fire environment management system, which is just brand new out right now, is going to be picked up and used for new innovative tools. And so we're kind of on the front edge of that. I'm actually chatting right now, trying to fix some problems that have emerged in some code. So that it's this same kind of thing that we've been kind of jamming on for the last couple of years continues forward with our team.
And some of the things I'm working on is that database in some ways is a gold mine. There's a lot of interesting things to tease out of there. And so one thing I've started to look at, again, with this audience, people are probably familiar with like models of like recreation demand, trying to predict what recreation sites do people go to as a function of their characteristics and the function of the site. So one of the things I'm working on is kind of taking that, instead of it being recreation demand site visits, it's like, well, which websites are you visiting as a function of people's characteristics and in the characteristics of these, these different sites? Are they decision support sites? Are they, you just get basic information? Do you have to input data? So to kind of understand that mix of the person and the site and the combination to see where people are going. Another thing that's interesting is folks have done a lot of interesting qualitative research, like asking people, there's a few studies like why they do or don't use WFDS, or what do they use WFDS for. And actually a lot of we took things from qualitative studies and reframed them as kind of more quantitative survey questions. And what's interesting is that, well, I think most of the studies we base this on were done just interviewing folks in the Forest Service. Our survey is going beyond just people at the Forest Service. And one of the interesting things we found was that in the qualitative studies, people report or saying, like, most people are telling us this. And that this, whatever it is, tends to be the mode response, the most common response. So our quantitative stuff is reinforcing the qualitative research. So it's kind of like not an either or. We wouldn't have had our quantitative questions if it weren't for the prior qualitative stuff. And so again, what we're finding just reinforces what folks have found already. But the other thing is that with the other qualitative work, they'll say, well, most people are saying this. But what you could also tease out from what we're doing, it's like, well, most isn't everybody. So what explains, like, everybody doesn't feel this way, or everybody doesn't use the data or not use the data. So what accounts for those differences? So we're kind of going in that direction. But I think it really shows the strength of kind of going back and forth between qualitative research and quantitative. It's not either or.
Yeah.
I'm really sold on them reinforcing each other.
That's great. And I would say from the, not that I can speak for the whole Southwest Fire Science Consortium, but I think that the consortium would be very interested if things come up as you delve in deeper that either point to how we can do a better job sharing kinds of information, the right kind of information, et cetera. It feels very useful, particularly for organizations like the consortium that's whole goal is kind of information dissemination bidirectionally. So, um, yeah. And we have a question in here that came in from Jeffrey. I'll read it out, but you can obviously read it as well. Of the tools you identified people were using, was there any data regarding what aspect of the tool they were using? Subset of features, right? Because some of these tools are pretty large and complex. And were they using individual values to synthesize a value, which is a datum that informed their decision?
It's such a good question. I'm sure I interrupt you,
Yeah.
but it's such a good question. And sadly, the answer is no, in that initial data set, because it was already a very large and unwieldy survey, and George did a fantastic job of putting together and analyzing it. But I wish we had that. But this is what what George was just saying about this is a truly like mixed methods team. And it's actually pretty much a, textbook inner and transdisciplinary team, the way we're working. This is a sort of qualitative question, in my opinion, because it would be so complicated to try to like dig in on a survey on that depth. So I'm hoping that kind of thing is what we can do. So thanks for that question. It's not a dumb question at all. In fact, it's front of mind. The problem is the limits of these tools are big and complicated, and it's sort of like you really have to get in and understand what people are doing with them to really, like, in some ways what we've done is fairly naive, which we recognize. But anyway, not a dumb question, great question.
Yeah. Yeah. I could imagine like you almost need to do case studies or focus groups or something to like watch how somebody uses it. Yeah.
Exactly.
Good. And then Catherine has another question for the scientific community generating some of these indices or data. Which gaps or signals did you see in user surveys that we, the scientific community, can use in thinking about the venue or the types of data that the scientific community generates? And then the second part is any ideas about early testing of data that we're generating to test its utility?
I guess I'm unmuted, so thanks, Phil. Um, Well, I mean, I'm not sorry, Catherine, I'm not going to directly address this because I don't have a great answer to your questions. What I will say is what we have found ourselves doing is we didn't talk about it at all, but this process was quite unusual in that it was a very interactive group of people working together on this. And we were engaged with Chuck, who got us kind of connected to the fire community. And so we were sort of didn't know much at the beginning, to be blunt, about how the fire community worked and stuff. And so I think the advice isn't go be embedded in the fire community to make your tools, but I do think there's some level of what Mike talked about with the burn period tracker. We really had to understand a lot more before we could be very useful. And so that's, again, not particularly helpful advice for the community at large. At the end of that second paper, the Weather Climate Society paper, we did kind of conjecture that we think this more engaged process probably does result in more robust tools because you have direct engagement, you have a lot of back and forth. Again, that's common in the literature, not just in this community, but otherwise. But we recognize it's time consuming and it's challenging. So yeah, not a great answer, but that's where we're at.
Well, and I would say that's part of what the consortium is trying to do. So if there are folks, Catherine or others out there thinking about tools, if there's a way that the consortium can help kind of connect the folks using the tools and the tool developers, I think that's part of our role. But Mike, do you want to add?
Yeah, I'll just add a quick thing. It's interesting in the creation, talking with Chuck and connecting with operational fire meteorologists and then the fire planners and behavior analysts. They're very, very sophisticated consumers of weather, but trained up in a certain way. And relative humidity is a very standard use of meteorological data going back very, very far. The climate science community is really pushing vapor pressure deficit. And I remember learning vapor pressure deficit in a thermodynamics class in my undergrad, and that was it. That never came up again until more recently. It is a very powerful metric, but we can't expect it to just, emerge within that community. And so we've talked about this as trying to crosswalk relative humidity and vapor pressure deficit gradually over time and train people up. And I think they'll see the power of it. But the burn period being sub-daily has a real powerful utility on its own and could be used in complement with some of these other indices we're seeing that are really useful in sort of climate change aspects as well. And it's just an engaged, slow effort to, I think, really get these things to get some traction on the ground.
That's great. And if folks have to leave, we're at the top of the hour, but if some of our presenters can take a crack at the last couple questions here, and it's really about the influence of agency and other variables for influencing the usage of different tools. And maybe,
Yeah, I'll follow up on that because that is exactly what we're going to do. Jeffrey's got the good questions today. Yeah, we are following up. That's the next study. We're just kind of scoping as Tristan's joined us just in the last couple of weeks, actually. Yeah, that's what we want to do is we do want to understand, like George mentioned this in the survey data, we saw what we started calling a dispatch center effect. And so we do think that there are influences, and I've been thinking of them in qualitative social sciences. I've been thinking of them as sort of culture, information cultures, like how do people use them. And so, yeah, we are going to dig in on that. We're right now scoping out a next set of research questions. And we do want to understand not just agency, but, sort of where people are in their career. There's a lot, I think, that probably would get us farther down the road of making stuff that was a little more useful.
I mean, we're finding, that there's this agency effect, but what is it about particular agencies? That is an open question. And there's some things where it's like people are supposed to use a specific tool, and the rate of use doesn't match the supposed mandate for them to use it. Or they may be using it, but they're not using it as pitched or is intended or promoted. So it's like, are you using WFDSS to make decisions? Well, no, they are using it to share information with other agencies. They are using it to document what they're doing. So even when people are told, you're supposed to be using this, they're not necessarily using it in the way it's been pitched as being used. And again, it almost, I think, as an economist, I've said, I think good anthropology can be better than bad econometrics. So if you actually get under the hood and talk to people about what's going on, and the thing that I think is worth exploring is that a lot of these decisions are group decisions.
yeah.
So it might be something like, well, okay, again, like if people are making a group decision, well, maybe everybody in that group isn't using the individual information themselves. There could be one person in the group and they're the one that's doing it, and everybody's relying on them.
Right.
And again, you see this in the qualitative literature where they'll talk about, well, in groups, there might be like, one person who knows this system. Well, what happens if they leave? So it might be, well, we don't have to have everybody do this, but that means you don't have any backup. You don't have any redundancy of possibly people in the groups being comfortable and skillful at using these data sets.
Very relevant when there are massive changes in federal employment. So feels very apropos. But we should wrap it up here. We're out of respect for time. Thank you so much to our presenters. Really great job. Clearly, a fertile area of discussion. And we'll post this video on the YouTube channel, etc., as soon as we can get to it. Thanks everybody for participating, and look forward to seeing you on future webinars, etc. Have a great afternoon.
Thank you, Xander. Thanks, everyone.